Here's a tutorial on net ionic equation. So it's basically, we're just going to do a double replacement like we did before. So I traded the partners, and the sodium went with the chloride and the iron went with the, it's called carbonate. And then we balanced it. We've done that kind of thing before. But really, everything on the left is dissolved in water. Otherwise, we wouldn't be talking about it with net ionic equation. So when it dissolves, it all separates. So there's my two sodiums, and they're aqueous dissolved in water. There's my carbonate. It is aqueous dissolved in water. Also, we put the charges. These were plus, that's -2. This is a +2, it's dissolved in water. There are two of these -1s, and they are dissolved in water. Now the question comes up, can you really make these? We can put it on paper, but can they really be made in real life? And if you look at the top of your solubility chart, sodium is a super soluble, and everything it attaches to dissolves just like that. So if we try to make table salt and say it won't dissolve in water, well, that's kind of dumb. Yes, it will. And so it will stay dissolved. These are not attached to each other. They are not solids. They are aqueous. And therefore, nothing happened to them. It was aqueous, dissolved in water. It's aqueous, dissolved in water. It was aqueous, dissolved in water. It was aqueous, dissolved in water. So that's why they're crossed out. Nothing happened to them. They didn't participate in the reaction. What really happened, the net ionic equation, net meaning after you take everything into account, is that these two met and formed that solid. So here again, I traded my partners, and I made a double replacement reaction, and everything over here is separated with its charges and aqueous, and then we go in to check our solubility chart. So sulfates are here, and they tend to be soluble, dissolved in water. And is cobalt an exception? No, it's not. So that would be soluble. So notice these stay dissolved in water, soluble. I have my charges, and I have my aqueous. What about magnesium chloride? Chlorides are also pretty dissolvable, and is magnesium an exception? No, it's not. So these also are dissolved in water, and what you get is everything crosses out because nothing changed. And so there really is no reaction, really. Nothing happened because nothing made a new gas or solid or liquid. Here's another one. I traded my partners, I balanced it, and everything on the left has its charge and is aqueous. And then we look at this one. Chlorides with copper. Chlorides, we always look for the anion, the one on the right. And is copper an exception? It is an exception. So instead of being soluble, these are actually pretty insoluble. So they're actually going to make a solid. And then this makes water, and that's an L. That's a cursive L. And so this is a liquid. So what we have then is two net ionic equations because these two met and fell in love and made a beautiful solid. And these two met and made water, and I forgot the little L. There we go. So when they're dissolved, we put the charges, and when they're not dissolved, we don't put the charges because the charges together add to 0.